Welcome to the deep dive. So today we're diving into a topic that sounds like pure science fiction. I mean, are we really saying there could be black holes out there smaller than an atom?
Yeah.
And even wilder, that they might be this dark matter stuff everyone's looking for? The research you sent over was pretty mind-blowing, so let's unpack it.
Absolutely. It's definitely a theory that's been getting a lot of attention. It really makes you think.
Yeah, before we even get to the atom size part, remind me again, why are we even looking for dark matter in the first place? We can't see it, right?
Yeah, exactly. It's invisible to us directly, but think about it. We see these stars and entire galaxies moving in ways that just don't make sense. Like, if all the matter we could see was all there was, gravity should work differently. So it's like there's this unseen stuff out there, this invisible hand messing with gravity. That's the dark matter idea.
Okay, now that is seriously spooky. But how do black holes, especially ones tinier than I can even imagine, fit into all this? They're not like the giant ones we see pictures of, right?
Right. Completely different beasts. These are primordial black holes, or PBHs for short. And dense doesn't even begin to describe them. Imagine, and I mean, try to wrap your head around this, cramming something like Mount Everest, the whole thing, into something the size of, like, a grain of sand.
Whoa, okay, now my brain hurts.
That's the kind of density we're talking about with these PBHs. Just unfathomable.
So we've got these ancient, crazy dense things potentially zipping around. Your notes mentioned a study that these PBHs could be passing through our solar system like every decade or so. I mean, first of all, how would we even know? And second, should we be worried?
See, that's what's fascinating. The idea is we wouldn't actually see the PBH itself. It's all about the gravity, right?
Yeah.
So let's say one passes by Mars. Even though it's tiny, its gravity is intense. So it would give Mars this tiny little tug, a wobble, and we could measure that wobble.
Wait, so we're talking about detecting something unbelievably tiny, a whole planet wobbling from something even tinier passing by.
It does sound kind of crazy, right?
Yeah, and how would we know it's a tiny black hole and not just, I don't know, like a rogue asteroid or something messing with Mars' gravity?
Ah, good point. Scientists have gotten insanely good at tracking planets, like down to the centimeter. A PBH flyby would have a totally unique wobble signature over time, different from what a regular asteroid would do.
Okay, so we're like cosmic detectives, looking for any little gravitational hiccup that seems out of place. It still sounds very if this, if that. Are scientists actually taking this PBH thing seriously as a dark matter explanation, or is it more of a long shot?
Well, for a long time, the hot topic was WIMPs, these theoretical particles, but we haven't actually found them, so that's kind of fizzling out. This lack of WIMP evidence makes people look at other explanations more seriously, and PBHs, well, they're looking more and more interesting.
So WIMPs are out of fashion, huh? What makes these PBHs so much more appealing? Like, why are they even in the running?
You know, it's funny. Sometimes the simplest explanation is the best one. PBHs would basically only mess with normal matter through gravity, just like dark matter seems to. No need to invent crazy new particles or forces to make it work. Plus, I don't know about you, but the idea of these tiny black holes being leftovers from the Big Bang, that's just inherently cool.
Oh, totally agree. That's some next-level cosmos stuff right there. But we've been talking about PBHs messing with planets way out there, like Mars. Wouldn't it make sense to look for their gravity closer to home? Couldn't we see an effect on Earth?
Bingo. You're already thinking like the scientists in the second study you sent over. They're actually looking for tiny changes in Earth's own gravity field, the kind of passing PBH might cause, instead of looking at planets wobbling.
Hold on. So we're using the entire Earth as a detector. How do you even begin to measure something that subtle? It's got to be insanely precise.
Oh, absolutely. We're talking cutting-edge tech here. This study uses data from those global navigation satellite systems, the same stuff that powers GPS, but they're analyzing the signals in ways most people wouldn't even think of, looking for these tiny gravitational blips a PBH flyby might create. And get this, they're using gravimeters too. Those are so sensitive they can pick up on the tiniest gravity fluctuations, like seriously tiny.
It's amazing how we can repurpose technology, stuff designed for, like, monitoring volcanoes or whatever, and suddenly it's giving us clues about the fundamental building blocks of the universe. But gotta ask, if one of these PBHs did come close to Earth, should we be heading for the hills?
Honestly, the chances of a direct hit are so astronomically small, it's almost laughable. I mean, yeah, space is huge, but even if PBHs are common, they're still incredibly tiny, spread super far apart. You're more likely to get struck by lightning twice while winning the lottery.
Okay, I can live with those odds. So this whole dark matter being primordial black holes thing, it's still a pretty out there idea, right? What's the general feeling in the scientific community? Are people jumping on board?
There's definitely a lot of buzz. It's like anytime a new theory comes along and shakes things up, you get this mix of excitement and a good dose of healthy skepticism.
Which is fair enough. We always say extraordinary claims need extraordinary evidence.
Uh,
We're still in the what-if stage here, right? Computer models, possible signals buried in data, but no actual PBH sightings.
Exactly. That's what makes it so thrilling. It's like we're right on the edge of something huge. We've got these tantalizing clues, but we're still hunting for that undeniable aha moment, that one piece of evidence that proves or disproves the whole thing.
And what if, just if, that evidence does show up, if we find out for sure that dark matter is made of these tiny black holes, what does that even mean for how we see the universe?
That's when things get really mind-blowing. It means that scattered throughout the cosmos, woven into the very fabric of existence, are these remnants from the earliest moments of the universe.
These tiny black holes, just out there everywhere since dawn of time. It's like, I know, they're holding the universe together.
I know, right? Makes you feel pretty small, in a good way, I think.
It really does. So let's say, hypothetically, we do get that proof, that smoking gun for PBHs. What then? Where do we even go from there? What could we learn?
Oh man, it would be huge. Think about it, we could finally understand how black holes form. Maybe even get a glimpse into the very first moments of the universe. Like finding the universe's instruction manual.
It's incredible to think about all those discoveries waiting to be made. What other cosmic secrets are we missing?
That's what I love about this stuff. Every answer just leads to more questions. We're always pushing further, and who knows what we'll find. It never ends.
Speaking of journeys, looks like we're at the end of ours for today's deep dive. Before we go, any last thoughts you want to leave us with?
You know, if we've learned anything today, it's that the universe is full of surprises and the most amazing discoveries. They're often hidden in plain sight. Makes you wonder what else is out there just waiting for us to notice it.
No, that is a truly mind-blowing thought to end on. A huge thank you to you for joining me on this incredible deep dive. It's been amazing.
The pleasure was all mine. Until next time.
And to all our listeners, thank you for joining us on the deep dive. If you want to learn more about these mind-blowing PBHs and the mysteries of dark matter, check out the show notes for all the details. Until next time, stay curious and keep exploring.